So in the given problem, he's asking the ratio of V0 by Vs. Actually, the output they have not mentioned here. This is the output V0. So to find out V0 by Vs, first of all, you just represent this with its equivalent of R model, or we can say this is called RT model or R model. So in this R model, we will be representing this FET with, so before that, so this is a terminal G and this is a drain terminal and this is a source terminal. So drain, source, gate. So when we are representing this with its equivalent R model, I will be representing with resistance RD in series with minus plus mu into VGS. This is D, this is S, and here G will be floating because these FETs are offering very high input impedance, so that's why this G point will be floating. So this is G. Now I'll exactly replace this with this circuit. So this will become RD. So on the top of that you have capital RD. This is connected to a DC voltage of 10 volts, and here minus plus mu into VGS, small gs or capital VGS. Then after this is the source terminal. So after the source you are having a resistance of RS. So this is RS, it is connected to ground, and here you will be having a terminal of G which is floating as I have drawn. Then from this G you are having RG and you are having Vs input. This is connected to ground. Vs. Okay, where is the output voltage? This is the output voltage. So when you are finding out V0 by Vs, which is AC gain, so you have to make all the DCs are zeros. That means you have to connect this 10 volts to ground. So when I connect this point to ground, how the circuit will be? The circuit will be G, RG, this is Vs, this is connected to ground, and here this will be RD, and this is minus plus mu into VGS, RS, and here this point is connected to capital RD which is connected to ground. So this is a ground point. What is the output voltage? Output voltage is this point. So now if you see here, you just apply KVL here. So when you apply KVL here, I will consider this as a current ID because it is flowing through drain. So what you will get here, since the current is flowing like this is a drop, this is a drop, and this is a drop. So when I write KVL here, this will become minus ID into RD minus ID into, sorry, this is I think capital D. This is capital D minus ID into RD plus mu into VGS, because this is rising minus to plus, and this is minus because this is going from plus to minus. So minus ID into RS equal to 0. So this implies I can write ID into RD plus small rd plus RS is equal to mu into VGS. Next, you see here, this is a terminal of S, right? So now I'll take this as a plus and I'll take this S as a minus, and then I'll write KVL here. So if I write KVL here, since it is open, there will not be any drop here. So this is minus to plus. So this is VGS minus to plus, no drop here. This is plus to minus, so minus VS, and this is again minus to plus, so this will be plus. What is the current? We have already seen the current is flowing ID, so this will be ID into RS. So from this, VGS equal to VS minus ID into RS. So VGS, you just substitute in place of VGS, substitute this value. So if you substitute here, ID into RD plus RD plus RS is equal to mu into mu. VGS, I can write VS minus ID into RS. So if I bring this ID term this side, ID into RD plus, here you will get mu into RS, it's already RS is here, so RD first I'll write. This is RS plus mu into RS, so mu plus 1 into RS is equal to mu into VS, right? Now this is V0. So if you see here, from here, V0 equal to, this is minus, this is plus, so this will be minus ID into RD. So this V0 equal to minus ID into RD. So from this, ID equal to minus V0 by RD. You substitute this ID value here. So this will become minus VD by RD. Sorry, this is not VD, V0. V0 by RD into RD plus small rd plus mu plus 1 into RS equal to mu into Vs. So from this, V0 by Vs equal to minus mu times RD divided by RD plus RD plus 1 plus mu into RS. So if you see the options, option B will be the matching, because minus mu into RD by RD plus 1 plus mu into RS plus RD. So option C is the right answer.